Okay, so today we're going to cover section 3. Before Christmas break, we learned about similar triangles, but today we're going to learn how to use those similar right triangles and find missing side lengths of them. So again, remember a similar triangle, we're going to have one small one and then a larger one. However, specifically in this lesson, we're going to be dealing with 3 similar right triangles. So the first thing we need to do is understand what it means to have a geometric mean. So again, for this lesson, we're going to be solving proportions. So a geometric mean can be found when you're given 2 numbers, you're going to multiply them, and then find the square root of that product. Now, if you're given a proportion, you're going to cross multiply. But notice one of the diagonals here are going to have the same letter. So this is where the square root will come into play. So if I find the cross products here and I multiply x times x, I get x squared. And then if I multiply a times b, I get ab. Now remember when we were doing Pythagorean theorem, when we were trying to find c, it was always c squared equals something. I'm going to do the same thing here. To find out what x equals, I square root both sides. So x is going to equal the square root of a times b, which is the definition. So you'll take the 2 numbers, you will multiply them, and then you will square root that product. So let's try the first examples. So let's practice this. It says to find the geometric mean of the given numbers. So remember, the definition of a geometric mean is to multiply the 2 numbers and then square root the answer. So now, what I can do here, I have 2 options of doing this. I can either just take the numbers, multiply them, so 4 times 20, get 80, and then square root that. But then again, remember, if I need to break this down. So if you'd rather leave it unmultiplied and start out and just factor those, again, you've still got to break down the radical. So it might be easier to break it down from the beginning and then from there look for your pairs. So if you did the 80, now you got to go back and factor 80. Now, you didn't have to go back to 4 and 20. You could do 8 and 10, but you're still breaking it down. So let's say I did 80 and I said, oh, I know it's 16 times 5. And then if you're good at recognizing perfect squares, it automatically goes to 4 square root 5. However, if you have to do the whole tree and get your prime numbers, you look for the pairs. Once you make a pair, 1 comes out, 1 comes out. Nothing to pair with the 5. He stays underneath. So multiply everything that comes out and multiply anything that remained. So notice I got the same answer either way. So you can either multiply, but then you got to go back and break it down. So a lot of times it's easier just to leave it unmultiplied and start your factor tree with the 2 numbers. Over here, you can choose, again, to multiply 9 and 25, get 225, square root that. For those of you who have memorized your perfect squares up to 20, this is actually 15 times 15. For those of you who haven't, again, leave it apart. Do the tree here. 3 times 3, 5 times 5. I got a pair of 5s. And a pair of 3s. 1 3 comes out, 1 5 comes out, multiply it, I got the same answer as if I square rooted 225.
It would be just 15, right?
Yes, no radical. So when you pull it out and it's a perfect square, the radical's gone. Here is the first theorem of section 3. It doesn't have a name. Again, the number is not important to us. What's important is what it says. And I'm going to explain all of these words momentarily after you guys fill in what it says. So it says, if the altitude is drawn to the hypotenuse of the right triangle, then the two triangles formed are similar to the original triangle and to each other. Now, one thing that's important here is this original triangle needs to be a right triangle. So here is my original triangle. The altitude is drawn to the hypotenuse of a right triangle. So the original right triangle is outlined in yellow. The altitude of that yellow triangle is drawn from vertex A down to the hypotenuse. Remember, the hypotenuse is across from the right angle. From this altitude, I have now formed two smaller triangles. I've got a blue one on the left, and I've got a red one on the right. The red, the blue, and the yellow triangles are all similar. I need to write a similarity statement. The way that I identify the correct order for my similarity statement is I look at my hypotenuse. I find the hypotenuse of each one of the triangles, and then from that hypotenuse, move to the shorter leg. Now, it doesn't matter which triangle you start with, so I'm going to start with the smaller one first. So I'm going to do the blue triangle first. I'm going to identify my hypotenuse first. My hypotenuse of the blue triangle is side AC. Maybe I'll write it down here so you can see it better. So AC, and then from AC I go to the smaller leg, which is CD. That is going to be similar to the red triangle now. I'll move it up. And the red triangle, its hypotenuse is going to be BA. And from the hypotenuse, I go to the shorter leg. Next, I'm going to do the original yellow triangle. And again, the hypotenuse here is BC, going to the shorter leg, which is CA. Now, I will start you off on the quiz, and I will give you one of the triangles. I would like, for example, give you the blue one, and then you'll have to give me red and yellow. So I'm going to start out the correct order. From there, you'll fill in the other two. So if your letters for red and yellow are not in the correct order, you get it wrong. So the order matters here. Okay, so on the quiz, I'm going to start you off with one of the statements. From there, you need to match the other two triangles. So if I have gone from hypotenuse to shorter leg on my first triangle, you need to replicate that for the other two triangles. If I've gone from hypotenuse to longer leg, you're going to write the same order on the other two statements. So just make sure you look at the order of the letters. It is important. Okay, another theorem. This one is the geometric mean altitude theorem. So this one's going to help us find an altitude or a segment. And I'm going to talk about all the words in this momentarily after you guys fill it in. All right, so here again, notice we have the original large, let me see what color I'm on, the original large yellow triangle with its right angle up here. So again, when we draw down the altitude, remember it splits it into three different triangles here. Now, the altitude again is touching the hypotenuse. Where it hits, splits this hypotenuse into two segments. I've got segment 1 and segment 2. This is what I'm going to be using in this proportion. Notice here it's labeled as the altitude, and over here is segment 1, segment 2. So again, what we would do is multiply segment 1 times segment 2, and then square root it to get the length of the altitude. And we're going to do examples of these. But first we need to go through the second theorem, and that's going to be the geometric mean leg theorem. You need to memorize this proportion for the quiz on Friday. Theorem 7.7 is the geometric leg theorem. And this one has a lot of words, and I'm going to give you an acronym in a minute. But for now, let's get it filled in. So again, I still have the original, I'm going to do it in yellow, the original right triangle. And again, it's going to split that hypotenuse into 2 segments. So again, this would be segment 1, segment 2. X and Y in this figure, X is a leg and Y is a leg. Because again, remember, this side down here is the hypotenuse. So when I'm referring to the legs, I'm talking about the legs of the original large triangle. Now, this part of the proportion here, where it says segment of the hypotenuse, that's adjacent to the leg. Remember, the word adjacent means next to. So from this given proportion here, notice I have 2 legs in my picture. So from this proportion, I can actually solve 2 separate proportions, one for each leg. So Y is blue, and its segment of the hypotenuse that's adjacent would be segment 2. The segment for X that's adjacent to leg X would be segment 1. I'm going to call this segment of the hypotenuse adjacent to the leg, I'm going to call it SOHAL. I call that the SOHAL. So the segment of the hypotenuse that's adjacent to the leg. So that's the piece of the triangle, or the piece of the hypotenuse that's right next to the leg you're solving for. So if you want to solve for leg X, you're going to use segment 1. If you're solving for leg Y, you're using segment 2. That is your SOHAL. Okay? You need to memorize these proportions for Friday. The next slide, we are going to use the 2 proportions that we just learned. All right, first we're going to do A. I'm going to go ahead and again, remember this original triangle is a right triangle. I'm going to label the pieces that are given to me in part A. So it tells me that JR is 16. Let's do this in black. 16. EJ is 9. It wants me to go back and find all the other missing pieces. I'm going to add some variables in here just to make it easier when I write out my proportions. So I'm going to say my altitude is X. This leg over here is going to be Z, and this leg will be Y. So the first piece of information it wants me to find is HJ. HJ, notice, is the altitude. I've just called this HJX. The proportion I'm going to use to find the altitude is that theorem, the geometric mean altitude theorem. And again, remember that was segment 1 over altitude is equal to altitude over segment 2. Remember, the altitude splits this hypotenuse into 2 segments. So this will be segment 1. This will be segment 2. So now I'm going to fill in my information into the proportion. Segment 1 is 9. Remember my altitude was x. My altitude is x. And segment 2 is going to be 16. I'm now going to solve this proportion. X times x is x squared. And now I can either choose to multiply this or simplify it before I multiply. If you realize that 9 is a perfect square and so is 16, you could square root 9, square root 16, and x is equal to 12. If you chose to multiply 9 times 16, you would have gotten 144, and you could still square root that to be 12. Keep in mind, on Friday's quiz, there is no calculator. So my advice to you is I would keep it unmultiplied and break it down from there. It'll save time. So the length of HJ, or my altitude, is 12. The next thing it wants me to find is RE. How can I find the length of RE? Sophia? Just add 9 plus 16, because RE is down here. So 9 plus 16, and this gives me 25. Now I got to work on the legs. The legs is the geometric mean leg theorem. So let me go ahead and move over here. Remember that formula is hypotenuse over leg, leg over the Sohal. I need to do this proportion for Z, and then I need to do it again for Y. So the first leg I'm going to find is letter Z, which is actually they want, so I'm going to find Y first because they want me to find RH first. So RH is my Y. So my hypotenuse, remember, is that RE. It's 25. The leg I'm looking for is the letter Y. And the Sohal, or the segment adjacent to the hypotenuse of the leg, is going to be 16. I now will multiply diagonally, y squared. Now, instead of multiplying 25 times 16 and then breaking it down, leave it apart. Again, notice you have two perfect squares again. So square root of 25 is 5, square root of 16 is 4, so the length of this leg is 20. So the length of RH is going to be 20. I now need to do HE. HE I've labeled as letter Z. So again, the hypotenuse is still 25, putting in Z. The segment of the hypotenuse that's adjacent to leg Z is 9. Again, do the cross products. Z squared is equal to 25 times 9. I'm going to square root both sides. Again, 25 and 9 are perfect squares. I'm going to get 5 times 3, and you get Z equals 15. Bless you. So this leg is 15. So that's part A. We're going to do exactly the same thing for part B. I'm going to go ahead and redraw my picture here. I think that'll help us. All right, everybody good? That was just one problem, but finding all the pieces. All right, so let me just redraw the triangle. Here's my altitude. So segment 1 this time, JR Let me add in the letters here. H, R, E, J. All right, JR is 4. JH, this time they're giving me the altitude. So now from here, I've got to find the missing pieces again. Let me add in letters. This time, I'm going to put X on this segment, Z over here, and Y over here again. All right, so again, I'm going to use the segment 1 over altitude, and then altitude over segment 2. Again, this will be segment 1. This is segment 2. So segment 1 is X. Altitude is 2. Segment 2 is 4. So this one actually isn't a geometric mean. This one's just linear. So 4 times X, 2 times 2. So 4X equals 4. Divide by 4. And X equals 1. So segment 1 here is 1. The length of the hypotenuse, RE, is 1 plus 4. So RE equals 5. This is my hypotenuse. Now to find the legs, you're using this formula. You're going to be using hypotenuse over leg, leg over Sohal. Remember, we have 2 legs to find. So I'm going to first find leg Z. So for leg Z, again, my hypotenuse, I just found it. It's 5. I'm going to find Z. Its Sohal is 1. So Z times Z is Z squared. 5 times 1 is 5. So this answer is just square root, and Z equals the square root of 5. And Z was also HE. To find Y, which is HR, again, I'm going to do the hypotenuse over the leg, leg over the Sohal. Y squared equals 20. I'm going to square root both sides. Now, again, if you'd rather leave this as 5 times 4 and then break it down, break this to 2 times 2. And then you have a pair of 2's. So the square root of 20 is 2 radical 5, which is also the length of HR, or RH. This is RH. So the pieces they asked you to find were RH, HE, RE, and then we also found, this was EJ, or segment 1. Okay, so homework is on Canvas. You're completing the 7-3 assignment, 7-2 warm-up, and 7-3 warm-up. And we're going to go over all of this tomorrow to prepare for Friday's quiz. And again, no calculator for the quiz. And you will be doing multiplication of decimals, radicals, and two-digit numbers.